Alright, you are gonna need a highlighter. Alright, so we are going to be discussing independent dependent variables. Part of it, you want to think about it as like you've done in science. Has Ms. Sandoval covered independent dependent variables with you guys yet? No. Fair enough. She should at some point this year talk about independent dependent variables in science. If not, I don't teach science anymore, so. Let's talk about the word independent. What does that word mean to you? Not in math, just in general. What does independent mean? Case?
That you don't need anything else.
Right, kind of on your own, right? Okay. What does the word dependent mean? Cooper.
Means that you need other stuff.
You need other things. You need somebody or something in order to be able to do, yeah. So that's kind of what you're thinking about when you're talking about independent and dependent variables. The independent variable doesn't need anything. The dependent variable depends on the independent variable. It's kind of what you want to think about. So, like, for example, your parents are the independent variables and you guys are the dependent variables to your parents. You depend on your parents for rides, for money, for clothes, for help, for whatever. Okay? Alright, so this is just a little bit of information on the front side, and then we're going to take our notes and whatnot on the inside. So it says the independent variable causes change in the dependent variable. Alright, and then the independent variable obviously affects the dependent variable. And changes are caused by the independent variable. So again, the dependent variable depends on the independent variable. Alright, so here's an example of independent variables and dependent variables when it kind of comes to math and to science. So this is Jackie tested how the height of a ramp affects the distance a toy car travels. So your independent variable here is the height of the ramp. Okay? And the height of the ramp determines the distance the car will travel. So the dependent variable is the distance the car travels. So if the height of the ramp is really low, your car probably isn't going here. Or it might go further. If it's really high, it might go really high in the air, but won't go very far distance-wise. So the height of your ramp determines the distance of your car, or the toy car, or whatever. Alright, so now we're looking math side of this. What is that? What is this? Right here. What is that? Jackson.
Coordinate grid.
It's a coordinate grid, right?
Yeah.
Which quadrant is it?
It looks like the first one.
Yeah, so it's your first quadrant. So you know this is always going to be X, this is always going to be Y. In 6th grade, we don't deal with anything negative when we're dealing with independent dependent variables. Now some of you guys might have been exposed to slope already on Imagine Math. That's where those negative numbers come in dealing with independent dependent variables. We don't do slope, we don't do any of that. I don't even know if I'm going to be teaching you any slope or anything like that with the advanced part. We'll find out later. Not important right now. Something else you need to always remember though is your X is always going to be your independent variable. So your x-axis is always the independent variable. Your y-axis is always your dependent variable. So that's a little bit of a trick to remember, that X is always your independent, even if you're not sure. X is always your independent, Y is always your dependent. And you can go ahead and highlight down here. Alright, give me a thumbs up. Actually, go ahead and stand up when you have all this done, written down, highlighted, all that. Alright, go ahead and flip your paper open. Now, this should not be like an extravagantly challenging thing, but you and your group members are gonna match the independent variables to the dependent variables in this top part. Once you have them, you can draw a line, and then, stand up to let me know you are done.
So number of tickets sold is not a problem. Minutes spent. Time spent studying is test grade. Minutes spent exercising is calories burned. Are you stand up? Are you doing the bottom also? No. Alright, have a seat. Alright, the amount of sunlight goes with which one? Charles?
The height of the plant.
Height of the plant. Time spent studying, Anthony? Determines your test grade. Minutes spent exercising, Corbin? Calories burned. And then obviously the number of tickets sold is the amount of profit. Now, when I learned about independent dependent variables, my teacher explained to me like this. And it just kind of always stuck with me. And he just made it super simple. He said the amount of sunlight determines the height of the plant. The amount of time spent studying determines your test grade. Minutes spent exercising determines calories burned, and numbers of tickets sold determines the amount of profit. So independent determines the dependent. So if you can figure out the two independent, dependent, and throw the word determines in there, and it makes sense, you're good to go. Okay? So just think about it. You don't have to think about it that way. You think about it whatever way makes it easiest for you. But it is something that stuck with me from high school and on. And as you get into more difficult independent, dependent stuff, it might help. Not saying that it will or it won't or you have to, but it's just a little strategy I was given. All right, some of this you're gonna do as a group, and we're gonna check it, and then some of this we're gonna do together. The one thing we're gonna talk about is this. So you can show the relationship between the independent and dependent variable in a blank and in the blank. All right, how many of you guys can tell me what type of table that is, or that you think that is? What do you think? Jackson?
Never mind. I was gonna say it was a times table.
Nope, it's not a times table. What do you think, Cooper?
Is it X, Y table?
I mean, yeah, we could call it an XY table, but that doesn't tell us how to use that table, right?
Ratio table?
Nope, but I like that you're thinking about something that we have covered. You can use it similar to a ratio table. Like you might use the X to the Y, or use the X to determine the Y. Christian, what do you think?
I think maybe it might be a comparison table.
Cooper?
Is it like a unit rate table where they like compare units?
I forgot.
Some sort of relations table.
No, it's an input-output table.
Oh my.
No,
You input your Y, and the output is your X, or you put in your X. You input your X and your output is your Y, which should tell you that your Y is going to be your answer. Does that make sense? So over here, and I don't know why they have the letter and, A and, because it doesn't make sense. In a input and output. Now, our situation is Carly earns $9.50 for every hour she works. Alright, so the independent variable, what do you think is the independent variable? What do you think? Kaylee?
Time spent working.
Are you sure?
Hours.
Well, you just told me both. So is it
I'm gonna say hours. Hours spent working.
hours spent working? How many of you guys agree that it's hours spent working? Okay, how many of you guys say, I think it might be the other way around? So, Kaylee, I have a question for you. The hours spent working determine the amount of money she makes. Is that true? Because the amount of money she makes would not determine the hours she worked. Okay. Alright, so your independent variable is hours worked. And then obviously your dependent variable is going to be the money earned. So my independent variable, does that go on the x-axis or the y-axis? Okay.
X.
So that-
Independent.
Independent. Okay, are you sure?
Yes.
Alright, so that's going to be your x-axis, and this is going to be your y-axis. Alright, I have given you as much information as I'm going to give you. As a group, you are going to fill out this, the graph, you're going to answer this question, and you're going to fill out this statement. If you think you know the equation, write it. If you're not sure, don't worry about it. We'll talk about the equation in a bit. Okay? You will have, I'm only going to give you like 6 minutes. Alright, go.
So, we should start from 0 to 0.
It's like really close.
I'm not sure.
It's like a little bit of both.
So it's
And then for 3 hours, you get 27. Yeah, 28.
She gets $9.50 every dollar.
You're not breaking up the parts to work on this and that. You're working on each part as a group.
Yeah, no.
Every hour she gets
Every hour would be
Oh.
So for equation, why don't we just do or I have on the table?
Yeah.
Like that, and just like pick a random number. No, you can't put it. And you have to do 1, 2, 3, so X is gonna be hours, right? X by hours is
X is the X. And then the first one would be like minus 950. And then the second one would be
Oh, I see what you mean.
Yeah. So it'd be for hours.
X would be $19.
Yeah, because it'd be 9
Oh. Yeah.
So what is the relationship between X times 950? What is the relationship between
I mean, it would be like times 2. Or no.
No, the relationship. Yeah. So it'd be X times 950 since X is the amount of hours for every hour. Yeah. What would the relationship be for every hour? Like you get 9 hours.
Oh, yeah.
It's the same thing.
Yeah, you're right. I'll put like in this.
So just in between. Well, not in between, like right. Under. Yeah, under half. Yeah, exactly. So there'd be half. Yeah, under half and then half. Because there's X right there. Should we do number 2 or do we have to? I don't think we do. What? I just choose it. Oh, you gotta write like. Just kidding. Should we like put dots for how much it makes on the chart?
I know, then the
So 950 times hours. I'm gonna do one video, right? I wonder how much money she makes per minute. Wait, we just chill. Oh, no, we have to find the third one. We get a chance to chill. Wait, no. Like, to make it easier, could you do 9 quick on 6? So 950 times 6. It's 57.
So what about here?
A little bit under half. Yeah, 57. You would do 950 times 6. So a little bit under 50, or a little bit under 60. And it's my weather, so I don't think there's so you would a little bit above the
Yeah, and we couldn't even
So $85. I don't remember. Oh, yeah. Oh, so you
go ahead and go over this.
By the way, there's a little dot right there. You're a little dot. Guys, be quiet.
Alright. So let's go ahead and answer the question in the middle. It says, what is the relationship between the independent and the dependent variable? So what is our relationship here with the number of hours she worked and the amount of money that she earns? Cooper, what do you think?
The amount of hours she works determines the amount of money she earns.
Amount of money she makes,
She earns.
earns. Alright. So we have to know how many hours she works. So can we jump over to our graph yet, or do we need to do our table first? You have to do the table first because look, X and Y. This is technically your X coordinate, this is technically your Y coordinate. Alright, so what is the X represent? If you had to use one word to represent your X axis or your X coordinate, what's that one word? Hours. Okay, and then if you had to pick one word for Y, what would that word be? Cooper. Money? Just money? Modify. Come together. I'll do the symbol. We'll use the word. Alright, so to make this very easy and kind of looking at the graph a little bit, what was the first number you put in your graph over here? Haley. Huh?
1, 3, 1, and 1 on the X on the X on 9, $9.50.
We already know she makes $9.50 an hour, right? Plus, if I'm looking at my graph, that's going to be extremely hard to graph, right? How many of you guys did? Why would y'all do the hardest numbers in the world? Look at your graph, y'all. Yes. Say it again. Right. So make it easy, like as easy as possible. If you're looking at your graph and you see 3, 6, 9, 12, 15, 18, 21, 24, why on earth are we going to pick a number where we got to figure out, okay, I think it's somewhere like right in here. Don't make it hard on yourself. All right, so if she works 3 hours, how much money does she make then? So 3 hours, how do we figure it out? What do we do? Christian.
Well, we're gonna first multiply 3 by 9.50 or 9.5.
Okay, and then what do you get?
You get 28.50.
So you get $28.50. Okay, so then if you did 6, huh? Y'all made it really hard on yourselves. Our graph is going to be fantastic. All right, so I'll show you a couple different ways. So if you do 6, you're going to do 6 times 950. What did you guys come up with when you did that?
$57.
And then the last one would be 9 hours, and we're going to do 9 times 950, and what would you come up with?
85.
All right, so no matter what numbers you put over here, though, what was the thing that we always did that was the same? What did we always do that was the same? Cooper?
We multiplied by 9.5.
Right, so our y equals $9.50 times X. That is your, sorry, you can't see that. That is the equation. You can use that equation, 950 times X will always give you your answer of Y. How many of you guys got the equation right? Good. Good job. What do you mean you just switched around? That's fine. Yeah, as long as your Y is equal to your 950X. Alright, so let's slide over here to our graph. So again, we have it fairly easy. We're gonna do 3 hours and 2850 is about there. 6 hours, 57 is about there. And then 9 hours, 8550 is about there. You know if your graph is going to be correct because your line is going to be straight. Okay? If your line, and I'm going to use an extra sheet over here. If your line goes point, 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 and you go like this, that's not right. Okay? Your line should be straight, either up and down, going this way. It should not be, your dots should go in a straight line. Alright, Michaela, you said your group did what numbers? Okay, so 1 gave you 950. 2 gave you what, 19?
Yes.
And 3 gave you 2850. Alright, so if you're gonna graph this over here, 1 is over here, 950 is like right there. 2 is like right in the middle, 19 is right there, and then 3 and 28 is about there. So you have a much smaller graph to work with. But you should be able to see that it is in a straight line. So again, those of you who pick different numbers, make sure that line is straight. That's how you know if you're, oh wait, because that's way more important than what I'm talking about. Just make sure that your line is straight and you don't have this crazy dot way over here or way over here. The last thing that we need to do with our graph is we have to label. So what is the bottom of our graph? What are we going to label that as? Jackson?
Hours work.
Alright, and then the y-axis for
Money earned.
and how do you guys know that the hours worked goes on the bottom and the money earned goes on the up and down, vertical, whatever that is? River.
Because the independent is always X.
The independent is always X, the dependent is always Y. Alright, go ahead, you can fold this, and this is really nice because it tells you where to put your glue. See that? Glue this side. We gotta keep it simple. First week back, I don't wanna make it too hard on y'all. Why are we whistling?
They're staring at you.
Alright, so today we're not going to do a ton of in-depth practice with this. You guys are gonna do this very simple sheet right here independently. We're gonna go over it, and then you're gonna get an exit ticket, and I'm gonna grade it. Because I need to know if we got it or we don't. So if we don't have it, then I need to stop, and I need to really rethink how I have planned for the rest of this time. Okay? So, once you have everything glued in, leave this out so that you can actually use it. Work on this, stand up when you're finished. Alright, so when you're done, you're standing up and letting me know that we are good to move on. Alright, let's go ahead and talk about this. This says, use the graph to answer the question. So the title of this graph is Museum Ticket Sales. The x-axis is telling us the number of people who attended, and the y-axis is telling us the cost of admissions. Alright, what else do we know about the x and the y? What else do we know? Michaela?
The X would be independent and the Y would be dependent.
Okay. Is that gonna be important?
Yes.
Okay. So obviously it says identify the independent variable. So So knowing that our X is going to be the independent variable always, we know that our independent variable is then what? The number of people. And the dependent variable is obviously the cost of admission. If we knew how much the museum made on their ticket sales, would we be able to determine the number of people that attended?
Yeah.
Only given no, you would not.
know how much they did.
Right, you have to know how many people went and how much they paid. So for 5 people, it was $30. Could we figure out how much it is per one ticket based off of that information?
Yes.
Would I be able to figure out how much it cost per one person if I only knew it was $30 and I didn't know how many people attended?
No.
No, so that is where you really have to think and say, does this make sense? Yeah.
If we had the cost of admission, like how much, these, whoever got, and we knew how much each ticket was, couldn't we figure out how many people there are?
Yes, but that wasn't what I asked. What I asked was if we only knew the cost, we would be able to determine the number of people, like, or the amount per ticket. So you wouldn't be able to without knowing the number of people. Does that make sense? Alright, so then obviously this bottom part down here, it says describe the relationship between the independent question and the dependent variable. So what's the relationship? Someone tell me what they wrote. Hunter.
I said the number of people depend on the number or the cost of admission to get like for the museum ticket sales.
Are you sure?
I think it's so I thought it was
Does he need to change one word?
yeah.
Okay, what's the one word he needs to change and then he will be 100% correct? Amazing. Needs to change to. No. Okay, what you would say, the number, what is it, what's the word? You were right, we need to change the pen to something else. What did you write? What did you write?
It says the number of people equals cost of the admission equals how many people.
So you flipped it around. And that's okay. Guys, this is new. That it's okay if this part of it we get confused, that's why we're going over it. So please do not get embarrassed. Like that's why we're having this conversation. And that's why I'm having you guys do this on your own because this part is easy. This part is where it's a little bit more difficult. Okay? Alright, so Hunter was kind of right, but we need to change the word. Mason realized by talking that he flipped some stuff around. So Caleb, help us out.
I wrote the cost of, well, for Hunter, the word he needed to change depends into determines.
Okay. So the word instead of depend, you need to have determines. Okay? You were there.
I
You were
don't know
close.
when that would like a big meeting.
Yeah. Alright, and then how can we help Mason? He has cost for as the independent and number of people as the dependent.
Well, the cost doesn't like tell you how many people went, but like if you look at the people and then you look at the cost, you can kind of determine how much one person paid. But if you look at the cost of the people, it's kind of hard.
Okay? So you just need to flip your cost and your people. Yes.
So if you say that the cost of admission depends on the number of people, would that still be correct? It wouldn't
No.
have to be the number of people.
Because then you're flipping your independent and your dependent. Based off of our graph, based off of the information that they gave us up here, we identified that the independent is the number of people and the dependent is the cost. Now, if cost was down here and number of people was up here, then yes. But you can't just flip them because of the information that was given to us.
But since you're saying depends, wouldn't that make it the dependent variable?
We're not saying depends. We're saying determines. He
Yeah,
had,
I meant like if I said that like the cost of admission depends on the number of people.
yes, but then you're changing it. You're changing your independent and your dependent variable. And again, I'm not saying you're wrong. You're right, but based off of this question and this information that they gave us, your independent is the number of people and the cost is the amount of the admission. Because of your graph. Now, if you had a blank graph and you wanted to put down cost down here and number of people here, that's fine. Because essentially what you're gonna learn with independent, dependent variables, they can be intermixed, depending on how your graph looks. At the end of the day, on the EOG, what you guys need to know about independent, dependent variables is the equation and how to plug a number in. That's really and truly what you need to know. And it might ask you, what is the independent variable, what is the dependent variable? It's not gonna be this in depth, but if you can understand this, then you are 100% good to go. All right, so understanding the graph, understanding your X and your Y. Who are you waving at? Understanding your X and your Y, that the X is the independent, the Y is the dependent. And then tomorrow, the activity that we're gonna do is 100% practice in plugging in numbers from a graph and making sure that your graph is correct. Because that's really and truly what you're tested on. And at the end of the day. All right.
I understand fully.
So we said number of people will determine cost of. All right. Exit ticket. This goes into the third period bin, and I shifted the bin around because you guys kept knocking the leg off on one of the days they were gonna fall off. So please make sure your first name, last name, date, and period is on this, and then turn it into the bin, and then get started on the math. If you're done with the math, you may work on Lexia. If you are done with Lexia, you need to work on something that is gonna keep you quiet. You can glue this little sheet of paper into your notebook on the side that says independent dependent practice.